Alright, so I've had quite a few students have difficulty with writing linear equations and word problems, so I'm going to be doing a few problems here, and hopefully if you guys watch this video, you guys will be able to do it a little bit easier. Okay, so one thing we are always going to be working with when we're writing linear equations is we're going to write it in the form of y equals mx plus b. Just remember, m is the slope, which always goes next to the x, and b is the y-intercept. All right, so we need to find the slope and the y-intercept for each of these. All right, so let's read this problem and we'll kind of write some numbers down and make a table and all that good stuff. All right, so right here it says Mr. Mole left his burrow that lies 7 meters below. Now that's kind of important. If you're 7 meters below the ground, that's going to be like -7. All right, so he started out, okay? He started out, before he even started digging, he started out at -7, which means 7 meters below. And then he started digging his way down deeper and deeper, descending. So key word here, descending. That means he's going what? He's going down. So our slope's going to be negative at a constant rate. After 6 minutes, so 6 minutes, he was at 16 meters below the ground. All right, so I put -16 because 16 meters below means negative. Now, where did I get the 6 and as one of the x values? X represents minutes. So it says complete the equation. All right, so there's a couple of things you could do it by hand if you want to. It's not that big of a deal. All right, so at 0 minutes, he's at -7, and after 6 minutes, he's at -16. So you can see how he's going down. So how much does this go up? That goes up by 6. So the change in the x is 6. What's the change in the y? Well, he went down 9 more meters. So that's called the change in the y. So if you do this by hand, the slope would be the change in the y over the change in the x. So I'm going to put -9 over 6. Now that reduces to -3 over 2. So that's my slope. So right now I know my slope's going to be -3 over 2x. Now I've got to find my b value. So, oh wait a second, that was easy. What's my y-intercept? -7, because at 0, you have to be able to identify your y-intercept. So there's my y-intercept right there. So I'm just going to put -7. Okay, cool, I'm done. I found my slope. They gave me the y-intercept, so that's all we need. So I'm going to put -3 divided by 2 x minus 7. So see if that works. Hey, we got one right. Let's keep going. All right, so we have a charity organization that had a fundraiser where they sold each ticket for a fixed price. After selling 200 tickets, they had a net profit of $12,000. They had to sell a few tickets just to cover the necessary production cost of $1,200. All right, let y represent the net profit in dollars when they have sold X tickets. Now, some of you may not know what profit is, but profit, just so you guys know, profit, put P, equals the revenue minus the cost. All right, the revenue, that gives you your profit. Whatever you sell minus whatever it takes to pay for something, it's called the profit function. But right now, let's go ahead and just kind of make a little X in the Y table, okay? Now, understand that after they sold 200 tickets, they made a profit of $12,000. So these tickets are pretty pricey. And, it cost $1,200 to put on the production. So before they sold any tickets, so 0, we're at $1,200. All right? So what I want you to understand, we got to find the slope and we got to find the y-intercept. But, I messed up here. That's a negative, sorry. My apologies for those of you who are watching. That's a -$1,200 because if it cost you $1,200, that means you went into debt $1,200. So my b value is -$1,200 or $1,200. All right. Now, let's say I rearrange the table here and make it a little bit easier for us to interpret the slope. Sometimes it's easier to count up than it is to count down. So we start out with 0, -$1,200, but then we go at 200, and it gets us up to what? 12,000. Okay. What is our gap? in our x's? What's the change in our x's? That's 200. And what's the gap between 1,200 and 12,000? Okay? Well, that gap is 13,200. That's the change in the money. Now, the change in the y over the change in the x. If you're wondering what I did right there, I went from 1,200 to 0 is 1,200. Okay? And then I had 12,000 and I added them together, and that's how I got the 13,200. So change in y over change in x, I'm going to take 13,200, I'm going to divide it by 200, and that's going to give me my slope. All right? So all we're going to do is we're going to take the old graphing calculator, type in 13,200 divided by 200, gives us 66. So that right tells us the price of the ticket. So it looks like it costs $66 per ticket. That's going to end up being my slope. Now in Desmos, if you have 2 points, you could type these 2 points into Desmos or the graphing calculator. So if you're doing the graphing calculator, here's how you would have to do it in the graphing calculator. You'd have to hit Stat, Enter, then you type in 0, and then you type in 200, and here you would go negative 1,200, and then you would do 12,000. There we go. All right, and once you type it into your stat editor, you can hit Stat, right arrow, go down to number 4, which is your linear regression, and just press all the way down here and get your slope and your y-intercept. So there's your slope and your y-intercept. But if you're using Desmos, okay, very easy. Do the same thing. Make your table. Start out with your ordered pair of 0 and negative 1,200. And then after 200 tickets, they sold, or they made a profit of 12,000. Here you just got to remember the phrase that pays, which is y1 tilde mx1 plus b. And you can still see you have a slope and you have a y-intercept. There's your slope, there's your y-intercept. So that gives me all the information that I need to write my answer. So I'm going to write my answer as negative 60, not negative 66. My apologies. It's been a day. 66x minus 1,200. All right, so we're just going to write it in. So there's our cost, there's our price per ticket, and we're done. Yay, we got it right. All right, so we have Kaden is a stunt driver. One time during a gig where she escaped from a building about to explode, she drove at a constant speed to get to the safe zone that was 160 meters away. All right, after 3 seconds of driving, she was 85 meters away. All right, let y represent the distance in meters from the safe zone. So she's going towards the safe zone, so her distance is decreasing. So if her distance is decreasing, because she's getting closer and closer to the safe zone, that means her slope's going to be negative. So I know my slope's going to be negative. But we're going to do something real quick. We're not going to do it all by hand. We're just going to go ahead and use Desmos. We're going to make a little table, x1, y1. We have 160 meters away after, that's how far away it is. Okay, so before she starts driving, so it's 0, we got 160. By the way, that's our y-intercept. Okay. And then after 3 seconds, she's 85 meters away, and that's just a point. Now we can find our slope by hand by finding the change in the x and the change in the y. That goes up by 3. 160 minus 85. That gets us 75, so it's going down 75, so down 75. So our change in y is negative 75 over 3, okay? And so that's going to get us negative 25. So that's our slope. That's our m value. This is what's called the change in y. This is called the change in x. So there's our slope. There's our y-intercept. So my equation is going to be negative 25x plus 160. But let me show you how to do it in Desmos real quick. It won't take long. So let's look at our Desmos. Got 0 and 160. And then after 3 seconds, she's at 85. And there you see it. There's your slope. There's your y-intercept. So negative 25x plus 160. There you go. Now, why is the slope negative? The reason the slope's negative and not positive, she's going towards the safe zone, so her distance is decreasing, which means it's going down. If she was going away from something, then the slope would be positive. I know it's kind of hard to visualize, but if you're going towards something, your distance is decreasing. If you're going away from something, your distance is increasing. All right, so Carolina is mowing lawns for a summer job. For every mowing job, she charges an initial fee plus $6 for every hour of work. Her total fee for a 4-hour job, for instance, is $32. So we got to do a little bit of math here, okay? Not too much, but a little bit of math. So let's think about this. She charges an initial fee, okay? But she also charges $6 for each hour of work. So basically, that's her slope. That's her rate of change. Her slope is $6 per hour. We have a table here. And the table, for instance, says after 4 hours of work, it's $32. So we have an X and we have a Y value. Just remember, it says X represents the hours. So what I like to do is I like to put Y equals MX plus B. And for the Y value, I'm going to plug in the 32. For my slope, I'm going to plug in a 6. And for the X value, I'm going to plug in a 4. I'm going to multiply the 6 and the 4 together and get 24. And then I'm going to take away 24 from both sides. So when I take away 24 from both sides, I get 8. So it looks like she charges an initial fee of $8. So her y-intercept is 8. That's her initial fee. That was the $8. So we had to find that. So our equation is 6x plus 8. So how do we do this again? All right, we take the 4-hour job. We put a 4 and a 32 because y represents the number of dollars. X represents the number of hours. So we make a table. It tells us our rate of change because it says it's $6 for each hour of work. So that's the slope. That's the constant rate. Then we take the y value, plug it in for y. Take the x value, plug it in for x. Take the slope, plug it in for the slope. Multiply those together. Take it away from both sides, and boom, you're done. That's all you got to do. Easy peasy. Hope you have a wonderful day. Hope this was helpful. Bye for now.